So we're going to do our curve sketching homework here based on our lecture. I want to remind people though that I do have for you online our set of curve sketching guidelines. So you may want to refer to these guidelines. We have vertical shifting in this, so you can take a look. We even have horizontal shifting. Okay, that horizontal shifting, horizontal translations, left and right. And we also have reflection about the x-axis here. So we're going to reflect our curves as well about the x-axis. So this homework was based on horizontal shifting, vertical shifting, and reflection about the x-axis. And you can consult for examples here, that worksheet I handed out to you. I also want to remind you that these are curves every B student should know. So you may want to reflect too on that worksheet, because you're going to have to know every one of these curves here. Okay, so we're going to test you on how to translate and reflect about the x-axis, all of these curves. And you see some examples on the worksheets. Here's the curves: square root, cube roots, fourth roots, fifth roots, sixth roots, absolute value. So take a look at these curves here. They're all going to be on my website. You can access them, and these are for the students who are taking trig, so it's not necessarily college algebra students here. But we're going to move these curves around in this homework assignment, and of course we do the same sort of thing for relations, like a circle, hyperbola. The two types, ellipses, and here's kind of a summary of the even and odd, I should say, powers here for some of these functions and how the graphs look similar. So we're going to refer to all of these ideas here like I've given to you in lecture to do this homework. So the title of this homework is Curve Sketching, and what we want to remind you is you're first looking at here a parabola. So that's x squared here. The highest power there is 2. And when you have a plus 3 here, okay, this is code for shifting your curve, your parabola curve, up 3 units here. So in blue, you can see outlined a parabola. I already did this partly for you. So we're going to move every point here up 3. So this origin, the vertex, is moved up 1, 2, 3 units. This is the location of our new vertex. And then all we have to do now is sketch the parabola. So it'll look something like this. So this is your curve of y equals x squared plus 3. So this is just an upshift of 3 units. We'll leave, or I should say, number 2 for you guys. This is going to be working only on the odds. And in this case here, I want to remind people, this is the absolute value curve, which is why you see the absolute value curve, or I should say the graph, in this picture. But now you have minus 2 units here. So we're going to subtract 2 units there, which means we really have a downshift. We're going to shift down 2 units, because that value for k, minus k, means go down. Plus k means go up. So that value is going to be important to determine how we move this curve. So this curve here is going to go down 2 units. Now I have a special point there again. It's kind of the origin, if you will. It's not even a vertex, but it's vertex-like. We're going to move every point, especially that point, down 1, 2 units. So my new point there would be right here at negative 2. So we can actually locate that. That's negative 2. Like in the prior problem, we went up 3, so we can say that this is at 3. And so that's fine. And now we just have to actually sketch the curve like we did prior, meaning draw these lines here. just like what you see above. Now this is just a sketch, it's not very accurate. And so this is how we graph the curve of y equals the absolute value of x minus 2. It's a downshift. So we look at this next question, number 5. This question here, I'm going to point out, we have the square root curve, which is why you see the square root in this picture. But because you have here minus 4, that simply means we shift the square root curve down 4 units. So when you go down 4 units, we're going to take this special point again here. This is the origin that's on our curve. We go down 1, 2 units. So it has a new location. That's right there. And all we have to do now is sketch again the square root. Now the square root will go up forever. But the idea is that you're moving this down 4 units. And this now starts at that value. And here's the sketch. Now, if you like, you can do a much nicer sketch where it kind of seems parallel, but this increases forever here. So just want to remark about that. And all we're doing is sketching these curves. So as you can see, it's important for you to know for all these questions the family of curve that you're talking about. So in this first case, parabola for x squared, the red portion. Number 3, absolute value. That looks like a V. Number 5, the square root curve. So let's see what kind of curve we have here for the next question. And in the next question here, this is x to the 3rd power. So if you remember in class, we kind of described this curve here as a snake, and this is the curve that you see in the picture. But because you have here plus 1, that's an upshift. So you have to shift up 1 unit because it has that plus k value here. These are the k's. So that would be up 1. So we're going to take again this point here that you guys see. That point is 0, 0 on the curve. That's my kind of reference point. I got to move that up only 1 unit. And so the new location will be right here. That's at the value 1. So I can label that 1 here. And now I just sketch the rest of the curve to look like this snake, if you will. And that's just a sketch of how this looks. It's not the nicest sketch, but it's a sketch. So remember, you have to know the family you're in, and you have to know what adding a positive number there and subtracting that number means. If it's plus k, up k units. Minus k, down k units. Number 9. Now, I want to point a few things out here about number 9 here. Here's kind of important to notice. That's a parabola again, x squared. But don't overlook this negative sign. See, that negative sign means you're going to reflect your curve about the x-axis. And the curve you reflect is right here. You're going to reflect this curve. And reflecting that curve now about the x-axis, you put your mirror across the x-axis again. So here's our x-axis. We put our mirror, and we tilt the mirror down so that we can see the reflection of the curve. What that now gives you is something that looks like this. This is actually the minus x squared curve here, sorry. Minus y equals negative x squared. So this is reflected about the x-axis here. Okay, so we have the x-axis over here. We have our y-axis. This is what they're talking about. So I know I have to take this particular curve that's reflected, not the original curve here. Right? This is y equals x squared. I use that as a reference. This is now reflected. I have to move this curve in such a way, and we say how. This is plus 5 units, so I move this particular curve. I shift it up 5 units. So this point is now 1, 2, 3, 4, 5, and we see that the program that created this graph puts that at 10, so that means every dashed line is not actually 1 unit, it's actually 2. So let's try that again. 1, 2, 3, 4, 5. So I go up 1, 2, 3, 4, 5 units. That's my new reference point. That's going to be at 5 now, so I can locate that at 5. So now I get to sketch this downward facing parabola. And this is the curve y equals minus x squared plus 5. And again, it's just a sketch. And I'll get rid of my reference here. And there you go. So this is how we start to sketch these curves here. But again, remember, we do need to remember that anytime you have a negative sign in front, we're going to reflect about the x-axis here. Okay. Number 11. So if we take a look here, we're going to notice that the power here is 2. So this is why you see here as our reference this curve, this parabola, y equals x squared. But this time, notice what we have in parentheses here. We have minus 3 units. So what we put down earlier here on your curve sketching guidelines here, that when you have this f of x minus k, this kind of worked the opposite here. This is now a horizontal shifting, left or right. And when it's minus k, like in this case, minus 3, we actually have to shift to the right k units, meaning we shift to the right 3 units here. Here's that k value. And when it's negative, it's actually a right shift. This is the negative I'm talking about. So we're going to go to the right 1, 2, 3 units. And actually, if you look at the spacing isn't quite right here, because this is at where 2 would be. So 3 is going to be somewhere in the middle between 2 and 4. So it looks like we have 1, 2, 3, 4. So right here would be 3. It's between 2 and 4. So it looks like every space here is 1/2. 1/2, 1, 3 halves, or we should say 1/2, 1, 1 1/2, and then there's 2, 2 1/2, and then we have 3. So each one of those dash marks are actually a space of 1/2. So this is where a 3 shift would be. And then I might remark that, notice this. This is something we discussed in class. In some sense, you're also moving that y-axis 3 units. Because remember, this is my reference curve. So everything is shifting 3 units to the right because this is minus 3, this minus k. So when I sketch this curve now, I get to sketch it as a parabola. And it will look something like this. It's moved to the right 3 units. So everything's moved to the right 3 units, every point. And so we can clean this up a bit. Remove this. These are just guidelines. And here's my right shift because I have minus 3 here. It satisfies this relationship. So this is a right shift question. Now notice 13 here. We have the absolute value. But this is going to be here, f of x plus k, where this k here represents the shifting to the right or the left. Now, since k is positive, you're going to move to the left two units. It's always moving k units. This is my k value. There's the positive value, so you're going to move to the left 2 units. Now, if you look at our graph here, it's not like we're moving 1, 2 here. Again, every dash mark represents a half. So what I can see, if I move to the left 2 units, and again, I'm moving this origin to the left 2 units, this is where my new origin is in a sense. And again, if I move my y-axis 2 units as well, it'll be simply over here. Again, the spacing is not 2 dashes, but this is where 2 units would be, where negative 2 is. So now draw your lines here. So this point now is over here to the left 2. Excuse me. We can now start to sketch these lines. And this is a left shift kind of question. And if you want, we could draw a nicer line here, but it's hard to see what's happening with the iPad there. Anyway, this is how we shift 2 units to the left this time. Now 15. We got the third power, so it's that snake. But we'll have to look at the details here. Because we have here this minus 6 here. So inside, that means we move to the right here 6 units. Because this is minus 6, and it works the opposite. If it's negative, it's to the right, and that number is the number of places you move. And then don't forget, out here now, we have plus another value. Now, k here is going to be that 2. Right? This is your other value. So we're going to get rid of that and say, if this is that k value, since it's plus k, that means we go up 2 units. Now, if you notice here, I have an issue with spacing here. So it's kind of a bad graph that they gave us with this, meaning when I have to shift my snake curve, right, and I think of first shifting that origin, I have to move to the right 6 units and move up 2 units. However, this represents 2 units, and this is 4 units, so 6 units would be out here. So maybe we'll just do that. We're going to go all the way out there, even though there's no lines there. So I have to move to the right 6 units, and I have to move up 2 units. So I'm moving this reference point, this origin, to the right 2, 4, 6, and then I move up 2 units. And so let me be careful. It looks like every dash represents, let's count. 1, 2, 3, 4, 5. So every dash represents 2. So when I move up the 2 units, it's just at this line here. Let's be careful. So this is the location of my new origin in a sense. And if you like to draw, those lines like we did before, draw a new x-axis, a new y-axis. And we can also verify whether we're actually on that location. We can just adjust this. So this is kind of like our new x and y axis right here. That's my new location. That's my new origin. The address of this new origin is actually going to be 6, 2. So I'm moving this location to the right 6 and up 2. And I get to now draw and sketch my snake here. So here we go. going to be careful. And that's essentially how this curve will look. I'm just going to clean this up. So this is how you graph a curve that looks like this. And there's two kinds of translations here, both horizontal and vertical. Number 17. We have the square root curve, which is why you see the square root graph. But this time, we have to shift this curve. Since it's -1, this gets shifted down 1 unit. So I take this point here, this origin, and I go down 1 unit. So again, it looks like every dash is 2 units. So going down 1 unit, I'll be right here. Let's make sure we can see that. So this is at where -1 would be. I now have to sketch my square root. And that's the graph of y equals the square root of x -1. That's just a downshift of 1 unit. Now, here we have two kinds of shifting again. We have both a horizontal shift and a vertical shift. Okay, let's see what we do here. Okay, so let's remember here, we got +3 here. So that means we have to move to the left 3 units. We also have -1. So that means we're going to have to also move down 1 unit again. So I want to remark here that for an exponential function, you never cross the x-axis here. And that this location here is always special. That's where 0, 1 is, that point. And that's my new reference point. So I like to actually use this point here as a reference. I'm going to move that point. Okay? That point's going to get moved to the left 3 units and down 1 unit. So let's try to do that. We're going to go to the left 3 units. And as you can see, my spacing is interesting, that going to the left 3 units, that's again going to be right here. It's going to be between -2 and -4. That's moving this particular point to the left 3 units. So I move this to the left. That's where that -3 would be. And then I have to move down 1 unit. So from here, I go down 1 unit, and I'm on the x-axis. So this is the location of my new reference point. But because I'm moving down, I'm also moving this imaginary x-axis down 1 unit as well. So I'm going to sketch here an imaginary x-axis. It's going to be down 1 unit. This will be the place or the location I never cross. So let's double check. This x-axis goes down 1 unit. My new reference point is to the left 3, down 1. Oops, it's an eraser. So I go to the left. This will be 1, 2, 3, down 1. So let's sketch the curve. And if you need to, draw your imaginary y-axis. That imaginary y-axis goes through this line here because I went to the left 3. So your y-axis went to the left 3. My x-axis is down here at -1, so when I sketch here, I have to go up through that new point and then up forever. So I just move this curve to the left 3 units, down 1, but also make sure you move this x-axis here down 1, because we went down 1 here. See this? And you never cross that imaginary line now. And this is how this curve will look. Of course, you don't need all this reference. You can get rid of it. But at the end of the day, you essentially need that curve. So this is how we handle 19. Now 21, we have to remember this curve here. So it might be good to maybe try to look back at the curves and remember 1 over x, how does that look? Let's find it here. There we go. 1 over x, just to remind you, has both an x asymptote and a y asymptote. These are lines we never cross. So just to remind you, you just never cross those lines. Here's the curve. 1 over x. So with our homework, we have 1 over x to the 4th, or x minus 4. Apologize here. So this is this x minus 4 here. So we focus on the fact that it's minus 4, which means we have a right shift of 4 units. And because you don't have any other number out here, like a plus or a minus, well, there's no up or down shift. This is strictly a right shift. And so what happens here now is we're going to move every point to the right. And you might say, well, where's my reference point? What I'll say that I use is I use my y-axis and my x-axis as references. So if I'm moving to the right, I'm moving my y-axis to the right 4 units. It's now over here. It's going through 4. The x-axis is actually horizontal, so it still stays the same. I just have to sketch my hyperbola now. So I'm going to sketch this way, because every point gets moved to the right 4 units, and then this is my curve. So I moved everything to the right 4 units. This is how we handle 21. Now take a close look here. We see again that negative. And so we're going to have to reflect, and I'll put this in red, or first I'm going to put my mirror again across the x-axis because we have to reflect every one of those points for that hyperbola about the x-axis. Okay, let's see how that looks to reflect this about the x-axis. I'm going to put it in red. And so if I put my mirror across the x-axis and I move it down slowly, I can see that every curve above here, or every point, is now down here. And if I do the other side, every point is up here. This is the reflection. So you're looking at the graph here of, in red, f of x is minus 1 over x. You just reflected everything. That's the curve I have to move. Now you might say, how do I move that curve? Well, if this is plus 3, okay, if you go back to this f of x plus k business, we know we have to shift to the left 3 units. So every point is going to be moved to the left 3 units. Now, since I'm moving to the left 3 units, I recommend you move your y-axis, since it's vertical, 3 units. And this is moving to the left 1, to the left 2, here's to the left 3. So we're going to the left 3 units. This is where -3 would be. And when we really sketch this curve now, we're sketching the curve in red. So we draw here our hyperbola, never cross the x and y axis. And essentially, this is how this looks. So we don't really need all the reference. I'll get rid of that. I'll get rid of this. But this is essentially the curve here. This is how it'll look. And we just simply reflected about the x-axis and moved everything to the left 3 units. (25). Let's remember here. We have an 1 over x minus 2 squared. So we have to remember the curve here of f of x being 1 over x squared, and it's actually outlined already in purple. So we have that reference for us. We just have to remember, what does it mean to have f of x minus k? Well, that means we shift to the right k units. In this case, k is 2 right here. So we have that minus again, 2, which means go to the right 2 units. So I recommend you move your y-axis to the right 2 units, and this is where the location would be now. So we're going to move that y-axis to the right 2 units. Here's 1, here's 2. So our curve doesn't have any sort of plus or minus value here. So it's just simply a strict right 2 units sketch. And so let's sketch this all to the right 2 units. Now remember, you never cross even the x-axis. This has an x asymptote. So just draw your volcano. Never cross your y and x axis, or in this case, the vertical line here. This vertical line, by the way, has the equation x equals 2. You never cross it. That's kind of like your new y-axis. You just shift every point to the right 2 units for this volcano here. Let's go back to 1 over x. So this next problem here, we got the 1 over x curve, and it's outlined already. But because we have plus 4 means we have to shift up 4 units. Because plus is an upshift for 4, so we move every point up 4. Now, because you have an x and y asymptote here, remember, you never cross this imaginary line. I have to move that up 4 units. So this would be 1, and this will be 2. Because it's 2, 4, 6, 8, 10. Okay, so you're going to move everything up 2 units here. So start by shifting the x-axis up 2 units, and notice there's no effect for the y-axis when you move that up 2 units. All we have to do now, since we don't have to do a right or a left shift, we don't have to do a horizontal shift, is actually sketch our hyperbola. So here's my new x and y axis. If you want to think of it that way, never cross this line, and just sketch your hyperbola here. And it looks a little bit different. It doesn't look exactly like that. Let's get this here. Let's draw a nicer sketch here. Okay. Just something like this. And these are arrows. These go on forever in those directions. So we just move this hyperbola up 4 units. That's all we have to do. (29). We have 1 over x squared. But this time, there's a minus 3. So that means we have to shift down 3 units. So we're going to shift this volcano down 3 units. So I recommend shift your x-axis down 3 units. And so if this is 1, this is 2, this will be 3. Here's the location of your new x-axis in a sense. This is going to be y equals -3. I'm going to have to move every point down 3 units. Notice my y-intercept does not go down at all. So what I'll do is start to sketch my graph with my new x-axis, my new volcano here. Every point is shifted down 3 units, so it's going to look like this. There you go. It's just a sketch. Again, if we look at this reference curve, this is the hyperbola. But this time, notice what's happening with your shifting in the hyperbola here. We got minus k. And what that means is we're going to have to shift to the right 4 units. But I also have +3. And that means I have to shift up 4 units. Sorry, 3 units. That's the value 3. So here's 3. That means +3. We go up 3. And that -4, remember it's backwards. You go to the right 4 units. So every point gets shifted. Now, because you have you have x asymptotes and y asymptotes here, we're going to shift both the y and x axis right 4 units, up 3. So let's start here by in red. We're going to have to move the x axis up 3 units. So here's 1, 2, and 3. This is the equation y equals 3. We're going to also have to go to the right 4 units. We're going to shift this y-intercept to the right 4 units. And that looks like this. Here's where 4 would be. And that's actually, by the way, x is 4. So in some sense, this is my new x and y axes. And I just have to draw now my hyperbola with these new axes. And that's all we do. So that's all it is. It's just a sketch. Now we get a nice log function. And you have, for a log function, you actually never cross the y-axis here. Okay, there's the y-axis. Here's your x-axis. But because you have -3, that means we have to shift to the right 3 units. So I'm going to go to the right 3 units here. I start by moving my y-axis to the right 3 units. So here's 1, here's 2, and here's 3. So I got a new y-axis in a sense. This is the line here. X equals 3. And all I have to do is sketch my log function. Now I also want to remark about the log function. We do have a reference point. This point here has an address. That's the address 10. Now that's important because the log curve then is always to the right 1 unit. That'll make this point, if I move 3 units to the right, this is my new reference point. That's 40 there. So I know I never cross this new imaginary y-axis, and I just increase like this forever. And that's shifting the log curve to the right 3 units. So it's an important point to locate that reference here. And that's moving to the right 1, 2, 3 units now again, that particular reference point. And here's your sketch. We have a similar curve here with the natural log function. So with this curve, we have plus 5. So that means you shift to the left 5 units. But because I have a minus 4, that also means I shift down 4 units. So I'm going to move every point to the right 5 units, but down 4 units. That's really moving my asymptotes, or I should say my axes. And it is moving the asymptote because the y-axis here is an asymptote. That gets moved to the left 5 units. So let's take a look at how that looks. Here's 1, here's 2, here's 3, here's 4, and here's 5. So here's the location of my new y-axis. This happens at the vertical line here, x equals negative 5. That's where negative 5 is. I also have to move, though, my x-axis down 4 units. So I move everything down to the left 5 units. I move everything to the left 5 units and down 4. So my x-axis goes down 4 units as well. So that means if every dash mark is 2, so let's move this 1. All right, every dash mark, this is 1, this is 2, 3, and 4. So I have a new x-axis, and that happens at y equals negative 4. So I'm going through negative 4 now. So I'm shifting my axes by the criteria that we noticed. Left 5, down 4. And I'm going to recommend you also pay attention to that particular reference point, that address, because I'm going to move that too. So that point is actually 1, 0. So if I move it to the left 5 units now, this particular point, I'm going 1, 2, 3, 4, 5 units, and I have to go down 4 units now. 1, 2, 3, and 4. So this is the location of my new reference point. That's going to the left 5 units and down 4, so I can sketch this curve. Make sure you never cross that new imaginary y-axis, and you can increase now up forever. This is moving everything to the left 5 units, down 4 units. And again, if you want to go back and say, do I need all this reference? Not necessarily. We can clean it up. And this is essentially how this looks. I may want to keep this just for fun. That address moved to the left 5 units, down 4 units. Anyway. Okay. A nice quadratic, and we see that quadratic already there. Minus 5 means we shift to the right 5 units. Plus 3 means we shift up 3 units. And you say, what do I shift? I shift that origin. That's my reference. I'm going to shift to the right 5 units. And so that means this is 1, 2, 3, 4, and 5. Then up 3 units. So remember, this is by 2s. So this will be 1, 2, 3 in the middle there. That's the location of my new origin, if you want to think of it that way. The vertex. So I'm going to remark that this is my new x and y axes. Everything got shifted to the right 5 and up 3. And now I get to just sketch my parabola. And there you go. You may want to notice the address here is going to be actually 5, 3 for the new vertex. This is the absolute value curve. This is why I have that reference for absolute value. Now, again, you have plus 6 here. That's that plus k value, right? This is k. That means we shift to the left 6 units, and then we have this minus 2, which means we shift down 2 units. So to the left 6, and now down 2. Okay. So what I like to do is get my hands on, again, this imaginary sort of vertex. It's not really a vertex, but it's kind of similar. I'm going to move that particular point to the left 6 units and then down 2 units. So let's go to the left 6. 1, 2, 3, 4, 5, and 6. Then I have to go down 2 units, and that's going to be down here because remember, every one of those spaces represents 2. So in a sense, if I want to do this imaginary new y and x axes, it's right here. Oops. It's right there. Okay. And now sketch your V, I guess. Absolute value curve. And we're kind of off the charts here, but we can squeeze it in. Okay, so I move to the left here. Notice 6 units and down 2. So this is actually the location of our new address of -6, -2 for this new origin, in a sense, for your absolute value curve. Okay, that leaves us to now 41, the square root curve. So I already have my graph there for square root. And I notice again, let's take a look. Plus 5 means I move this to the left 5 units. The -1 means I move down 1 unit. So I'm going to move every point to the left 5 units and down 1 unit. Now this is going to be kind of interesting here. I'm going to have to ask you to think of it this way. We're going to do this here, since I can't really go to the left 5 units. Because here's 1, here's 2, here's 3, here's 4, and 5 is going to be really maybe out there. So I'm going to have to readjust this. Here's what I mean by that. Let's let every dash mark be 1 unit. So this will be 1, 2, 3, 4, and 5. Okay, so I'm going to do this here. Nope. This is going to be -5 here, right here. So that's going to the left 5 units. I can draw my imaginary y-axis now to the left 5 units. Then I have to go down 1 unit. And so I'm going to let this be 1 still. So my x-axis went down 1 unit, or here's the location of my new origin. So I'm going to move this particular point right here to the left 5, down 1. This is where I start now. And I just sketch my absolute value curve. And there you go. This address will be -5, -1 for this point here. So this is a way we can fix that graph so it can make some sort of sense for us. Okay, and now this will be 43. So let's remember you have the parabola there. That's the x squared curve. You guys already see the curve here. You see the outline. It's right here. But you also have a negative sign. So we reflect about the x-axis every point. So if I put my mirror there, let's reflect. Across the x-axis, let's move that mirror slightly down here. Let's bank it down so we have a reflection. And so what you'll see here is this parabola like we've been talking about. So this is actually the curve of y equals minus x squared. This is what we have to move. We should say this is -5, so we have to move that curve. You have to shift this 5 units to the right. Because when it's minus, that's a right shift. So if I do that, I'm going to have to shift now my y-axis to the right 5 units. And so this is going to be 1, 2, 3, 4, 5. So I'm going to be off this graph paper, but we can handle that. Shifting the x-axis 5 unit has no effect. So this in some sense is my new y and x-axes. And I can handle that now. I can actually draw the curve. So my new vertex, let's go over here, is the origin is moved to the right 1, 2, 3, 4, 5 units only. And now we get to draw our parabola going down. And that's the graph here. We just shifted everything to the right 5 units, but what we really shifted was the minus x squared curve. Now, again, you don't need this reference. And my new vertex will be simply 5, 0. We have a similar question here. Because we notice, first of all, we have the absolute value curve, which is why you see your V, but you also have a negative sign. So we're going to have to reflect every point here about the x-axis again. So you have this picture here. This is the curve of y equals minus x. So we're going to have to take a look now at what this means. Let's go back. And notice we have plus 5. Well, that means go to the left, shift to the left 5 units. We have plus 3. And you say that means you shift up 3 units. So we're going to have a left 5 unit shift and an up 3 unit shift. I recommend you start by shifting that origin. You move that to the left 5 units, which will be 1, 2, 3, 4, and 5. And then you have to go up 3. 1, 2, 3. So here's that new origin in a sense, that new location. I can have this x-axis here. Right, remember this is 3. Y is 3 is my new x-axis. My new y-axis will actually be x is -5. So from this location now, this new origin, I simply draw my inverted V, if you will. Now this address here for this new vertex, and it's not really a vertex, but it's really -5, +3, because I moved this point here to the left 5 units and up 3. Left 5, up 3. So this is all the reference information we need to sketch this curve. But again, if you want to have a nicer looking curve, we can get rid of all this other reference information. We can erase it here. Gone, gone. And if you like, you could just leave your imaginary new x and y axes. Okay, number 47. Number 47 here, we notice we have the x cubed curve, which is why you see the snake. But there's also a negative sign. So we're going to have to reflect now about our x-axis. So we're going to have to do an inverted snake, reflect that. So on the right side here, it looks like it's going to go down this way, and on the left side, it's going to go up this way. This is the reflection about your x-axis. Okay. So this is the graph here of y equals minus x cubed. Okay, so let's remember here now we have minus 5. So what that means is we go to the right, we shift to the right 5 units, and then we have this plus 3. So we shift up 1 unit. We shift everything to the right 5 units and up 1 unit. So we can again start, if you want, with that very special point, the origin, and we have to go now to the right 5 units. So looks like this is going to be, let's erase some of this here. Okay, so let's see if we can find that. Let's use a highlight. Let's go to the right 1, 2, 3, 4, 5 units. Again, we're off the graph. And then we have to go up 1 unit. So this is going up 1 unit. Maybe that's a little better. So maybe you want to draw here again your imaginary new x and y axes here. Okay. I think that's very helpful for me. So I know that this origin went to the right 5 units and up 1 unit. That means I'm right here. So now I just have to draw and sketch this inverted snake, if you will. So let's try that. And that's how our curve looks. Now let's notice that this new sort of vertex is going to be at 5, 1s, because I went to the right 5 units and up 1. This is the location. So that's kind of like my new origin, if you want to think of it that way, that new reference point. And there you go. We can clean it up. And this is kind of how it looks. .49 here. So if we want to see what kind of curve this is the square root curve. But let's be careful here with that square root curve here. There's a negative sign in front. So that means we have to invert, or I should say we reflect this curve about the x-axis again. And that's going to look like this. I'll put it in red. This is putting my mirror and reflecting down every point about that x-axis. Okay. Now, if we take a look, we have minus 2. That means we shift every point down 2 units. So this reference point again, let's undo that. Let's change that. This origin, we're going to go down 2 units. So here's 1. Let's do this again. 1. Here's 2. So my new point is here, down 2. So if you want to label that, we can, and that's at negative 2 now. So now let's remember, if I'm moving this, or every point down 2 units, I'm even moving my x-axis down 2 units. 1, 2 here. This is the line here. It's a horizontal line. That's the line y equals negative 2. So when I start to sketch this curve here, all I have to do is sketch that reflected square root curve. So here's the graph. And we don't need all this reference, so we can kind of get rid of some of this. But that's basically how this looks. That's all we need to do. Notice again, this is the hyperbola. But if we take a closer look, there's that negative sign. So what that means is we reflect every point here about the x-axis. This is all reflected. And now it would look like, if I reflect every point about the x-axis, here, here. If we tilt that mirror, see how this goes. This is going to be the curve. Y equals negative 1 over x. This is reflected. But if you have here a minus 2, that means we shift to the right 2 units. And then you have a plus 1, which means you shift up 1 unit. So every point is going to go to the right 2 units and then up 1 unit. Now it's helpful again for me to move my x and y axes, because I now have like an imaginary set of x and y axes now. And that's very good with sketching. So this is kind of like a guideline, since there's no real reference point, we should say. So let's move. If we move up 1 unit, that means you're really moving the x-axis up 1 unit. So here's 1. If you're going to move every point to the right 2 units, then you're moving the y-axis 2 units. So this is now going through that number 2 here. Here's my new x and y axes. So all I have to do is shade my inverted hyperbola. Looks like this. Just be careful never to cross your new x and y axes in a sense. So here's the graph. And if you like, you can remove a lot of this reference information. And essentially that's what you have here. I can't remove those curves, that curve in green there, because that was used as a guideline to help you guys with your homework. So here's how we graph this particular curve. 53. Remember, this is like the curve of 1 over x squared. And when I see this, there's a typo here. So let's do this here. This is a parabola. So here's what I'm going to say to you guys. This is a typo. Number 53, let's say note to self. We have a typo. Let's do this. This is f of x equals negative x minus 6 squared. Okay, so 53 has a typo. This is really what you're seeing. Let's get rid of this. You're not seeing that. It's not there. And so now this is going to make sense, because if I notice I have that negative sign, that's a 2. This is a parabola. But because the negative sign is there, we have to put a mirror across this x-axis and reflect every point. So I have this inverted parabola here. And let's deal with the shifting now. So we have a minus 6 there in my parentheses. So that means I move to the right 6 units. So every curve is moved, or every point there is moved to the right 6 units and inverted. So we only have a horizontal shift. There's no outside here plus or minus a value. So we don't go up or down at all. It's just strictly to the right 6 units. Okay. So let's move every point. And again, what I like to do is move this vertex. I got to move it to the right 6 units. So here's 1, 2, 3, 4, 5, and 6. So if we did have an extension here, let's draw an extension. This would be 5, and this is 6. Since I'm moving every point to the right, this 6 number of units, the 6 units, that means your y-axis is also going to the right 6 units. So you look like this. This is my new y-axis here. And so this vertex is now located right here, and I can sketch my inverted parabola down from the vertex. And if you remember here, we have a new axis of symmetry, the line x equals 6 here. And this is simply moving this inverted parabola to the right 6 units. And that's your graph. We can get rid of all this reference. And essentially, this is how this looks. Let's put that line back there. New vertex is 6, 0. Okay. '55, an exponential curve. So notice in this question, though, we also have this minus sign in front. So we have to, again, put our mirror across the x-axis, reflect every point. And so how that's going to look, if we look at the details, let me remark here. You go through that point here. This particular point here is at 0, 1. This is the address there. So when I reflect across the x-axis now, I'm actually going to reflect that point. It's going to be down here. So it's actually going to be down here at 0, -1. But every point is reflected. So I want to look at the detail and show you that it'll look like this. Get close to this x-axis. So this is actually the curve here of y equals minus e to the x. Okay, but we have plus 2 there. So that means we're going to do a shift here. We move to the left 2 units. Remember, if it's plus, it goes to the left. If it's minus, it goes to the right. So this is plus 2 units. And then we'll notice here you have minus 4. And for minus 4, that's going to mean you move down 4 units. So you're going to move to the left 2 units, and you're going to move down 4 units. So I'm going to take that original reference point. Let's see if we can find it here. Okay. That's going to go to the left 2 units. And so you might say here it goes 1, 2 units to the left, and it's going to go down 4 units now from that reference point. So going down 4 units, let's remember these lines here. This is actually 1, 2, 3, and 4. So this is the location of that reference point. I might put, again, here, this imaginary x-axis, because that's going down 2 units, it looks like. Yeah. Well, no, I take that back. Let's take that back. Sorry. That's the reference point. If your x-axis got shifted down, okay, let's write it there. Shifting the x-axis now down 2 units, let's take a look at what that'll look like. So here's my x-axis. I have to go down 1, 2, sorry, we're going down 4 units. 1, 2, 3, 4. Here's the location of our new x-axis. We move that simply down 4 units. Let's find the eraser here. So here we go. Let's double check. 1, 2, 3, 4. That's going to go through the line y equals -4 because we have to go down 4 units here. Good. And that now makes sense because if you notice this point is now over here. And so let's sketch our inverted here exponential growth curve. And we get close to this new imaginary x-axis, but we never cross it. So let's put it in black here. So it's looking like this, and then this goes down forever. So notice I just shift this curve in red to the left 2 and down 4 units. So this is kind of how it'll look. We can clean it up a bit. So we don't need all that information. '57. You have a log curve. However, we're going to notice that this log curve has this negative sign here. So we have to put along the x-axis our mirror. Now, I want to remark another detail. Let's take a look at this point here. For the log curve, you always go through this point 1, 0, and that's what this point is here. That's 1, 0. When you reflect this about the x-axis, you're going to tilt that mirror up. What you should see here in the reflection is a curve that looks like this. Sorry, let me take this back. Here's how this looks in the reflection. Now, here's the thing. We're also going to, if you take a closer look, shift every point here to the right 4 units, because this is -4. So this reference point is now going to go to the right 4 units. So here's 1, 2, 3, 4 units. So that new point is now over there. There is no up or down shift because you have no value out here. So if I move that reference point only to the right 4 units, I have to consider moving my y-axis here to the right 4 units as well. So if I do that, this would be 1, 2, 3, 4. That's the location again of my imaginary going through x is 4, my imaginary new y-axis, and I never crossed that. So at this point here now, what you can do now is start to sketch this curve. But be careful, it's the inverted log curve. So it's going to look like this. And you're going to get close. Sorry, let's do it a little better. Close to this imaginary x-axis, and you're going to go something like this forever. So this is how we handle that particular curve. Okay. And again, we don't need all this reference. And if you wanted to put the detail of this point here, looks like that's going to be 2, 3, 4. This location of this point is 5, 0. All right. Let's now go to 59. 59 is an exponential growth curve, but you have this negative sign. Some details again about this location. That's the location of 0, 1. That means x is 0, y is 1. You always go to that point. So when I put my mirror again across the x-axis and I reflect, that particular point is now going to be down here. Let's see what we can do. Let's put it in red here. Put the mirror. That location is now at 0, -1. And every other point is actually reflected as well. And we're going to get close to the x-axis but never cross. This is my inverted exponential growth curve, meaning y is negative e to the x. We're going to have to now add 4 units, which means we're going to have to shift every point up 4 units. So that's an upshift. Okay, so let's try that out. We're going to shift every point up here 4 units. There's no horizontal shift. There's no left and right shift. So that's good. And so let's try to shift everything up 4 units. So here we go. Okay, let's go up 4 units now. This is going to be 1, 2, 3, and 4. So this new reference point, let's put a black point there. That's going to be our new reference point. Since we're shifting up 4 units, we have to shift up 4 units our x-axis. So this is 1, 2, 3, and 4. So my new x-axis, be careful, is this line here. And that's the line y equals, well, it's kind of doing something funny. Y equals, looks like that'll be 4. Okay, so now I'm going to have to sketch my curve through this point now, and let's see if you guys can see this. We're going to go down here forever, and we get close to the new x-axis, but never cross it. That's shifting every point here in red up 4 units. And again, this location, this address would be 0, 1, 2, 3. This is 0, 4 for that address. And we don't need really all the other reference values. We can get rid of this and this. And here's essentially what the curve looks like. You can even get rid of this if you like. All that detail. We don't even need this. Oops. Undo. And that's pretty much how this works. So this is going over some homework questions for you. And just to kind of reiterate that this is all based on knowing all these families of curves here. This is a worksheet online. This is the curves I sketched for you guys as well online here. You start with a family. You have to know those curves. Those are expected to be memorized. And these are curves every B student should know. B STEM student, not B student, B STEM, business, science, technology, math, engineering, right? These are the kind of curves you know. I used to rephrase this as curves every calculus student should know. But I also want to remind you of the curve sketching guideline. This is the curve sketching guideline that we went over in class. We had reflections about the x-axis we talked about. So if you want to refer to these notes, you can. Let's go all the way up here. Sorry. These are curve sketching guidelines. You have vertical translation. This is what we talked about in class. We had horizontal translation. I won't go through those details. And we actually had that reflection like I mentioned. So this is putting everything together for your homework, and I hope you guys do well.